think I just did that.
Oh, the other day, Brittany, blah, 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 blah.
All right, let's, well, then I start recording that on the.
Did you hear what Brittany did?
All
Oh my
right,
gosh, Brittany.
all right, let's talk about some things here regarding, the finals. Go ahead and get, your sample 4 packets out, or 5, excuse me, sample 5. Let's get those sample 5 packets out.
I know exactly where that is.
Good. Good. Now, if you got all 28 problems done, you're ahead of the game. If you don't have any of the 28 problems done, you're behind.
Dang it, Miranda.
You maybe got half of them or so, you're right on,
Shooty bears.
probably right on track. Okay?
How does 4? That's about half, isn't it?
4 would be behind you.
No, I think that's about half.
But
I'm a math
you can
student.
easily get caught up, right? We're not so far out of it. All right.
District music contest is this weekend.
So, a couple of things I have up on the board here. First of all, the other class was interested in the scale for tomorrow's final. So tomorrow, we should call it a final with 14 days left. But anyway, the, 13 and a half. There's 28 questions. This is, tomorrow's test is just like, you know, what you're working on here in the first part of the packet. It's 28 questions, multiple choice, no calculus. 55 minutes, right? And this is the one we've talked about that is the most time pressure, I think, of all of them. On the midterm, we threw the free response in there, and so that gave you extra time. So we really have not had anything that we've taken that is this same amount of time pressure. So that is an issue. It's something you want to keep in mind when you do it. And for those of you taking the AP test, same thing. That first section with the no calculator, multiple choice, 28 questions, 55 minutes is, you need to be aware of that. Now, there's no penalty for guessing. We talked about that earlier in the year. You should answer all 28 questions. Make sure you get all 28 bubbled in. Okay, there'll be a scan sheet. Now, you can do your work right on the test, right, and then put your name on it because there'll be a sub here tomorrow. So make sure you put your name on that, name on the scan sheet, and we'll hand them back, and you can look and see what you did. But the way they grade it is they're either right or wrong. So this is the scale. So 20 out of 28 will get you an A. 15 out of 28 is a B, so that's a little over 50% for a B. 11 out of 28 is a C, and 7 out of 28 to pass. So what's that, 25%? 25% is passing.
Oh, so you
Okay.
can guess?
You can guess. Guessing is not
The
going to
probability of
penalize you.
guessing.
Okay? There's 5 choices, yeah. So you should be able to get 20% just by guessing, right? Yeah, you should be able to just bubble them in with your
Oh,
eyes
are there,
closed.
yeah, there are 5 choices.
Okay? But that's not enough. That's not enough to pass, right? So you gotta know something to pass. All right, or just get really lucky. Just get really lucky.
So just study one better and be lucky.
Study one day, you know. If your goal is to just get a D minus, then yes, that's okay. But
Okay.
hopefully your goal's a little higher than. Now, the class average in the past, well, it's been as low as 35%, but that was when there was a penalty for guessing. And so people would leave some blank if they weren't sure. And so typically they changed the AP test a few years back to take away that penalty for guessing. So it's kind of like SAT versus ACT, right? The SAT, isn't there a penalty for guessing? You lose. And on the ACT, you want to make sure above the line. It's kind of that same thing. Well, what happens is the percentage goes up a little bit once you take away the penalty for guessing. And what I've found over the years here as we've done this is it seems to be about 5 to 8%. The scores are better. I've never had a class do both, so I don't know for sure. But the average, the class average seems to be, it used to be pretty consistently in that 40% range, and now it's been, well, on this one it's been maybe even 10% higher. The average since we took away the penalty for guessing is more in the 50%. Now I adjusted the scale a little bit. The scale is not quite as generous as it used to be when the average was 40%. Here lately it's been more around 50, low 50s. So we'll see. We'll see how you guys do. On the midterms, you guys seem to be right in there with other classes I've had. So, so anyway, yeah, hopefully we, higher than that, that'd be great. But, so anyway, that's there. I don't know whether that helps you or whatever that does. I mean, you just, gives you a sense of where you want to try to be. But again, the time pressure, go through, just like these packets, probably the easier ones are towards the beginning. They maybe tend to get harder towards the end a little bit. But, don't spend too much time on one. Skip it. Go on. Make sure on your answer blank that you leave space and you bubble in the right ones. But come back, and then come back if you have time, because it's very likely that there will be some of you that will kind of feel like you ran out of time, that maybe you didn't get a chance to really spend time on every single problem. So you want to make sure that you spend your time on those that you feel confident in. Okay, so take that into consideration. Now the next one, next week is calculator. It's 50 minutes, but it's only 17 questions. So that's more like 3 minutes per question. So time pressure is still there, not quite as much. The idea is that if you're using your calculator, maybe that's taking you a little longer than writing, that kind of thing. And then the free response tends to be not quite as bad time pressure. Usually if you know what you're doing, you get done in time, and if you don't, it might not matter how much time. If you know what to do on a problem, you can probably get it done in time. If you have no idea what to do, an hour might not be 2 hours, whatever. So that's something to keep in mind. All right, now we're gonna, in a minute here, we're gonna talk over sample 5 and go through the, see if there's a few that you have some questions on. I have up on the board here number 11. If you get your packets out, maybe you can turn to number 11 real quick. Somebody asked about that this morning, and so I thought, and then somebody last period asked about it, so I wrote it up here. I'll just leave it up here. I'm not sure if we've run into this. Inscribed rectangles. Inscribed means inside, or in this case, under the curve. And circumscribed means outside or over the curve. So in other words, if you want inscribed rectangles, that could be a mixture of lefts or rights or something else, right? But it's, in this case, it would look something like this. So a couple of things. First of all, here's the equation. Well, you hopefully recognize that as a parabola. But to know whether the rectangles are under or over, you pretty much need to know what the graph looks like. So you really need to be able to FOIL that, factor that into x minus 3 squared, which tells you, oh yeah, this is just a parabola shifted 3 to the right. So then once you draw your parabola, then you can say, oh, okay, since I'm doing 4 rectangles, and 0 to 4, so they're each 1 wide. So this first rectangle would be a right, so it would be completely under. And it has to touch the curve, right? That's what inscribed means. It touches it, but it's under. And then 2 would be a right, and then the third one here would be a right, but the fourth one would be a left rectangle. So it could stay underneath the curve. And so when you add those up, you can see that, now you just plug these values in. So you plug a 1 into here, and you get 4. 4 times 1 is 4. Here you plug a 2 in, you get 1. And then these would both be 0, so the area is 5. Okay, so, but I just wanted to touch on that idea of an inscribed and a circumscribed rectangle, what that means. Okay? All right. Now, up here on the screen, because things are going to come fast and furious as we get in, once we get into the multiple choice, and we're going right into the free response, and then we got the AP test. And so I really want to be practicing some free response type stuff as we go along. Remember, that's half the test. That's half of the AP test. That's 2 of our 4 finals. The thing with multiple choice is it hits everything. It hits algebra, trig, and all those things. That you got to know all that stuff. And hopefully we've done enough packets. Maybe some of you feel like we haven't done enough packets, but
We've done enough
you might
packets.
keep that to yourself. But to go through and see these multiple choice type questions. But with the free response, we can narrow it down to some major topics, some major things that the free response questions are going to cover. And that, of course, is where you can really gain some points because you got partial credit. It's not just an all right or all wrong kind of thing. Okay, so I wanted to put this up here, and I don't know if you want to take a picture. I'll put it up here other days too, because I don't know how much time I want to take to write everything down necessarily. I could post it up on the website too. But I've got about 10 things here listed that are topics that you would find in a free response section. Okay? So, first one, position, velocity, acceleration kinds of questions. Some things that relate to that. Speed is the absolute value of velocity. Average rate of change is something we run into from time to time, and that just means slope between the endpoints. Average rate of change is just slope between the instantaneous rate of change is a derivative. Average rate of change is just slope between the endpoints. Okay? So there's usually a question that has something to do with position, velocity, acceleration. There's usually a question that has to do with area and volume, some region that you're going to revolve and find the area of and so forth. Sometimes in those questions you end up with average value of a function type questions, right? So a lot of these, there's like 10 different topics I have here. There's only 6 free response questions, but some of them they mix and match and put together in various problems. So somewhere you often see an average value of a function kind of a question. And so you need that formula. There's usually a question that has to do with chart stuff, max, min, inflection points, global max, min, like list of candidates or something like that, somehow showing that something's a global max, min. Sometimes we can do a number line with a global max, min that says, you know, it's always increasing before 2 and it's always decreasing after 2, so therefore it's a global max, that kind of thing. Okay? All right, the next page, and I can put this back up again later today if you don't get everything down. But okay, the fourth thing here. There's usually a question that has to do with tables of data. Now we did a packet with just tables, and we did a bunch of that stuff. And so, and we'll do some more in the packet as we come up. And I've got one more thing here to hand you with some free response type questions that we'll be practicing over the next week or so. So you get into questions like Riemann sums, like we were just talking about, inscribed rectangles or trapezoids maybe. Or maybe they want to know the derivative at 3. So in your table, you might take the point at 2 and at 4 and do a slope between them to estimate the slope at 3, that kind of thing. Number 5. Now I put in red what the key to this problem is. Now a lot of times this is mixed in with a chart problem, or you know, a position velocity problem, maybe something like that. But when you get g is equal to this kind of integral, that tells you that g is the antiderivative, right? That f is the derivative of g. And so you want to write that down, and then everything comes from that. So like if they want to know what is g prime of 7, but they gave you the f graph, well, g prime of 7 would be the same as f of 7, that kind of thing. There's almost always a problem that has differential equation initial value problems in it. So slope field maybe. Separation of variables a lot of times is a part of that. So you have to do some dealing with slope with differential equations. So I've got some free response questions we'll work on that have to do with that. Okay. Next page. Number 7, piecewise functions. Okay, there's usually a question, not always, but often a question that's got a piecewise function. That's where they typically ask you, where's this continuous? You know, it breaks at 7. So plug into 7, they got to have the same y values to be continuous. To be differentiable, they've got to have the same slope. You know, so a lot of times you see something like that. Related rate. Now, not always do you see this in the free response. This is probably more in the multiple choice, just because a related rate problem does not lend itself easily to doing parts A, B, C, and D. It's pretty much, you know, the sand is pouring onto the pile at 30 cubic meters per second. How fast is the height of the pile rising at 10 seconds? Or, you know, it's pretty much a one question kind of thing. So this one is not so much on a free response, but I've seen it in problems where they give you some kind of changing quantity and they'll stick in a related rate type question. Number 9, sometimes that related rate is a problem like this, an accumulation function, which is like a rate problem. They give you a function that is gallons per hour. You know, the oil is leaking out of the tanker at so many, you know, this function gallons per hour. How many gallons of oil have leaked out in the first 3 hours? Well, that should hopefully trigger in your mind, oh, I'm going to do an integral on that. Because if I do an integral of gallons per hour, that's going to give me gallons. I do the integral from 0 to 3. So that's called an accumulation function type question. Very, very often do you see problems that deal with that. Okay? I mean, we can go right down the line, 2010, 2011, 2012. You know, one year it was concert goers, and then the function W was the wait time before they got in. You know, the rate or the rate that they were entering the concert in people per hour, you know, and how many people got in the first 2 hours kind of thing, you know, and it was an integral, and it was, you know, that sort of thing. And the last one, this is usually fit into one of those other categories somewhere where you have a function, the equation of a tangent line, and then of course don't forget Shanghai or Luke Skywalker. And then this new packet I give you, the very first problem is one of those. Okay, so that's why it reminded me to put this on here. Doing the equation of a tangent line and doing a Shanghai or Luke Skywalker, 2 ways to write slope. Now, we may add to this as we go through, but I think this is pretty complete. So as you go through those 10 things, hopefully at this point in time, and this, you know, this is kind of the funnest time of the year, I think, for me personally, as this starts to come together. You know, as you go through those 10 things and you start to think, yeah, okay, those all sound familiar. You know, yeah, okay, I know what to do. So when you get into the AP test, you get into these finals, and especially the free response, and you start seeing these things, you're like, okay, yeah, I have a strategy for that. That looks familiar. Yeah, I'll try this, do this, see what happens. So that's it. I mean, that's a pretty decent summary of some of the major components we've had. Okay? So with that, I've got some stuff on the board here. So what we will do is I'll take some questions on sample 5, 1 through 28. By Monday, I will be here tomorrow. It's no calculator. So, you know, taking the test, there's not much I'll be able to do for you here anyway today. So if you have questions in the morning, I may or may not be here. I don't know. So I wouldn't count on coming in early and seeing me. But if you want to come in and work together, what I could do is, you know, I'll have the answer books either in here or in might have one in here and one in my office. So if you want to come in and double check some things, you sure could. But so the test is 55 minutes, so that should leave you 30, 25 minutes or whatever at the end of the period. You may want 25 minutes just to set and decompress after the test. I don't know. You know,
Amen.
whatever. I mean, that's up to you. But, you know, this is certainly something that you need, you know, you can use that time to get some of this done. Because really by Monday, you know, if you think about it, it'd be good to get most of this done. I mean, I'll take questions on this on Monday, but then we're doing the next test on Tuesday. So, you know, have a lot of that accomplished. And then this packet right here are some story problems, free response type problems, excuse me. And the first 6 pages in that I've listed up there. And so kind of be working on those. We want to steadily here over the course of the next week or so be working on these free response and brushing up on these free response problems. So, and I've got those worked out here. So I'll leave this with the sub as well. And so I've got these worked out if you want to check your work there. So really over the course of the next tomorrow, Saturday, Sunday, whatever. Like I say, you don't have to have these all completed when you come to class on Monday, but you know, it would be good to have knocked off a big chunk of this, and so I can take some questions and do some things, and then we'll have work time on those things. But then I'll also probably assign a few more in sample 5. We'll get into the free response, a few more in this other packet. We'll just kind of try to do a bit of time each day working towards those things. Okay, so let's see what you have on sample 5. Anything you want to talk about here? Number 5. Okay, here's one of those piecewise ones we were talking about. Now, we were talking about it in the free response, but it's often in here too. Okay. Question there about what? Just this one right here. So what do you think? What's the first step? F prime, right? Now what do? If you have two pieces? Do the slope of each piece, right? So the derivative of that would be 2x. The derivative of this would be 2. Okay? Now, we want the slope at 1. Now which one of those are we going to use? The top one, because the top one says when x is less than or equal to 1. So at 1, we would put a 1 in for x and we get 2. So the slope would be 2. Now, that tells you a little extras about this. What does that tell you about that piecewise function? It's differentiable at 1, right? Because what we would do is, since it breaks at 1, if we put a 1 in here, we get 1 plus 2 is 3. Put a 1 in here, we get 2 plus 1 is 3. So at 1, they both have a y value 3, which means it's continuous. But if their slopes are the same at 1, which they would be, they'd both be 2, then that means when they meet, it's a smooth transition. It's not a sharp change of direction. So this function would be both continuous and differentiable at 1, but you didn't have to do that for this one. You just had to get it back. Okay? What else? 17. Okay, we always tend to be bothered when we get these problems that have K's. There were several of them here. One was number, what was it, Dakota, we were talking about today, 20? Had a K in it. 23 had like an AB and a AB in it. 20 had a K in it. 23 had an A and a B. You know, just do the normal things you would do. I mean, it does change a little bit, obviously. But for example, what would we normally do with this problem? Forget the fact that there's a K in there. What would we normally do with an integral like this? Yeah, I would write that as 1 over x plus 2, and then I would do an antiderivative. What's the antiderivative of that? ln x plus 2, and then I would do a right bracket. Oops. And a right bracket. Oh, there's a K there. I didn't even notice that. Oh. And then I would put in a 2, and I'd get ln 4. That's a 6, not a 2, so I would get ln 8, thank you. And then minus ln k. Right? And then I would say, oh, I can't do anything else with that. Huh. Oh, wait a minute. That's supposed to equal ln k. So I'd say, all right, that equals ln k. So then what? Oh, yeah, 6, thank you. I would be doing well. I'm glad I'm not taking this test. Just for fun. Scale it to my score. All right. So ln k plus 2. There we go. So ln k plus 2. So now what? Divide right there. That, and remember, one of the things we've talked to a lot, I've talked about a lot here, is when you're doing this no calculator part, there's going to be trig, there's going to be log rules, all those things you got to know. When you when you subtract 2 logs, that's the same as dividing the log. Right? So this is ln of 8 over k plus 2 equals ln k. So what's that tell you? Yeah, 8 over k plus 2 has got to equal k. So now we can distribute that over to the other side. We get k squared plus 2k. We can subtract the 8. K squared plus 2k minus 8 equals 0. Factor it. K plus 4, k minus 2. So k is either a 2 or a negative 4, which it can't be negative because it says right here k is positive. So k has to equal 2. So, again, they get you on several things. Being able to do an antiderivative with natural log, being able to do a fundamental theorem part 2, but then you got to see that log rule of subtracting. And then it gets into some algebra stuff too. Okay? What else? Number 9. What is your question?
I guess that when I was looking through the answers, I just didn't understand why 0 wasn't included in 2 and 4.
Why it was included? You know, this is as I've read this one too, this is an interesting one to me. Because a lot of times, I don't like how it's where it says at which time t is its average velocity 0. And I guess usually average velocity is between 2 points, right? And so I think the implication is that at what time is its average velocity 0 from the time it started, okay? So from time 0. So to answer your question, and if anybody else wants to see more of this, we certainly can. To answer your question, to me it would be your average velocity is 0 when you get back to where you started from. So at 0, you are where you started from. But the question is, but did you get back? You didn't go anywhere, right? Well, if you didn't go anywhere, your average velocity is 0. You know, I mean, if I start here, go on, and then come back, my average velocity is 0. It's like displacement is what it is. I don't know.
I guess my only concern with that was I set up just the general integral 0 to a of the velocity equation over a minus 0.
Right, and if a is 0, you're dividing by 0. Yeah. Yeah, no, I agree. I just think, yeah, it is a little bit sketchy that they included 2 and 4, because it's not like we have a real formal definition of average velocity that also includes a 0 time period. Because if it is, think about average velocity. Remember, this is like average rate of change. If you're not following what we're talking about here, average rate of change would mean you take the position at point B minus the position at point A divided by B minus A, which is the same thing I think you're saying. You're saying if you take the velocity equation, which is x prime, from A to B, then you do the antiderivative, which is x, and you get this, right? So it's like your average value formula, if you want to think about it, okay? Or it's just slope between 2 points, same thing. So if point A and point B is point A, you get 0 divided by 0. It doesn't seem like that should make sense. And so, yeah, that bothers, I'll be honest, it bothers me a little bit on that one too. So, you'd have to, if that was on the EP test, you'd call up the people. Yeah, except you never do find out which ones you missed. So that's the problem. Anyway, anybody else want to hear more about that? Where that all come from? Yeah.
Yeah, they never got
Never got 2. Okay. Here's you do not you do not need to do the derivative here at all. Here's why. Here's why. Because it's the average velocity. It's not instantaneous, right? Instantaneous rate of change is derivative. Average rate of change is just slope between 2 points. So where the average velocity is 0 is just when this is 0. And this is 0 when the top is 0. Right? And so when is that 0? Well, when x of b equals x of a. In other words, when its position at point B is the same as its position at point A. In other words, your average velocity, remember, it's like displacement. So if I start here at 7, and I go for a while, and then I come back and I end up at 7, what's my average velocity? 0, because my net distance traveled is 0. So anytime I end up where I started, that's when my average velocity is 0. So all you need to do is put a 0 in see where this was when it started. So all you need to do is put a 0 in for t, and you find out you get 0. So this thing started at 0 on the x-axis. So when else was it at 0? Well, all you need to do is take this and set it equal to 0. Now, it's unusual. We rarely take the original equation set equal to 0. But what we're doing is we want to know at what times is the particle back where it started. So what you do is you set this equal to 0. What we're going to do is factor out a 3t. And we get t squared minus 6t plus 8. Well, that would be t minus 2 and t minus 4. And 3t here. So that's why we get t equals 0, t equals 2, and t equals 4. So the 3 times this particle is at 0 is at the beginning, and then at 2 it's back at 0, and then at 4 it's back at 0. I don't know which way it went, doesn't matter. At those places it's back where it started, so that's when its average velocity is 0, and then of course we get the Brennan discussion, but at 0, that's where it started, it didn't go anywhere. So down here you would have 0 divided by 0, and that doesn't seem like that should make sense, and I would kind of agree. Okay, so that's, you know, on this thing I had up here a little bit ago, that's kind of what I was trying to get at, is the sense that on this average velocity, average rate of change does not involve a derivative. So average velocity does not. Now, if you're doing average value of a function, that's a different question. Okay, that's this. Now, Brenna did write that when she, I don't know if you guys caught that when she said that, but she was talking about this as an average value, I think, didn't you? I mean, you can think of this as average velocity is like doing the average value of the velocity function. And I put it up here, but it might have went right by you. If this is position, the derivative of that is velocity. So that would be the velocity function. So the average value of that would be this right here, right? That'd be the average value of the velocity function. Well, if you do fundamental theorem part 2, the antiderivative of that is just x of b minus x of a, all over b minus a. So you can think of it that way, but what it really is just the position minus or divided by the change in time. So that's the way I approach it. Okay? All right, one more. Or no more. Yeah, Cody. Okay, what's your question there?
I don't remember what that.
The notation. Fair question. Help him out. What is it? Anybody? Second derivative. So what this is saying is y prime equals this. So what we want is second derivative, y double prime. Now, but there's more to it really than that. So when we do the second derivative, now we do have a product rule here, right? Let's go through it real quick. So what's the derivative of 2x? Leave the y alone. Plus 2x. What's the derivative of what? Y prime. But that's not any of the choices. Well, that's because we got a y prime here. Well, what should we do with that? Substitute 2xy right here. This 2xy is y prime, so substitute that right there. So we got 2y plus, and that'd be 2x times 2xy. That'd be 4x squared y. And so we get that. Right? So that's just second derivative is all that means. It's going to be an implicit differentiation. And then we got to throw that on there. All right, I want to make one comment about a later one, and that I brought up a minute ago was 23. And then I'll certainly help you, and you can look in the book, and you can ask me here when we have work time now. But I want to go to 23. I take it back. There are a couple here I want to just touch on. All right, 23, I'm just gonna give you a couple little pieces of advice on this. Now, again, it's got this A and this B, but again, don't let that throw you off. Just do what you'd normally do. Now, it says point of inflection. So what would you think of for inflection point? Second derivative, set it equal to 0. Now, you're gonna have some A's and B's in there, okay? So second derivative, set it equal to 0, but you'll have some A's and B's. But then they give you another important piece of information. They give you the point 20. Now, what does that represent, the 2 and the 0? The point of inflection is at that point. So that's an X and a Y value, which could be plugged where? Into the original. You can put a 2 in for X and you can put a 0 in for Y. And when you do that, that's going to give you something with A's and B's. So you're going to have two, you should have two things. Like Dakota, you ended up finishing. It wasn't too bad, right? Some nice things happened, things dropped out, right? We talked about that one this morning. So when you do the second derivative and set it equal to 0, you get some stuff with A's and B's. When you put that point in for your X and your Y, you get some A's and B's, and then you can figure out A and B pretty easily, I think. Okay? All right, so that was one comment I wanted to make. Another one I wanted to make was later here on, no, it must be back here. It was the one with the definition of the derivative, right? Limit as h approaches 0, isn't that up here somewhere? Which one? 21. Yeah, remember we've talked about this one, right? When you see that limit as h approaches 0, right away you're thinking, hey, that's just f prime of some function. What's the function? It'd be that right there, wouldn't it? So tell me what the function is. 2x to the 5th minus 5x cubed, right? Now, somebody in their class said they got thrown off for this part. Well, remember, it's f of x plus h minus f of x. Well, what they did is they don't have the parentheses. If you minus this, then that would turn negative and that would turn positive, and that's what happened there. But that's your function. So all you have to do is a derivative of it, and there's your answer, right? So you just have to look at that and think, okay, what function is that? This is definition, derivative, away we go. So that's one of the later ones, but it should be an easy one, you know, because that's really all there is to it. Okay, last thing I want to talk about is number 24. That's this inverse idea. Now this one you didn't have to know a whole bunch about inverse to get it, but there are some where you do, and I've seen these questions, so I want to throw it up there. But again, it's one of those where you're like, oh gosh, we haven't done very many of these, and I may just have to skip this one and go on. That's fine. But I thought if we do one here fairly close to test time, we might remember it. So this one's a little easier than most inverse ones, because you're given y equals x to the negative 1/3. Now, how do you find the inverse function? Switch the x and the y, and then solve for y. So if you can do it, that's what you want to try. But I will tell you, many of the times, you can't. But this one, it turns out you can. So now all I need to do is get the y by itself. Now, what do you do with that? And cube both sides. Actually, to the negative. If you would take both sides to the negative 3rd power, think about what that does. That's the quickest and nicest way to do this. Power and a power you multiply, so this becomes x to the negative 3, and this, you multiply those, you just get y to the 1st, which is what we want. So power on a power, you multiply the power, so that would be a great choice right there, a nice, easy way to do it. So now you're basically done. Now all you need is a derivative. So you got your inverse, now you just need the derivative. So it looks like it'd be e, right? But what I wanted to point out to you, so that was a little easier than most inverse problems are. What I wanted to point out to you is this. A couple of things about inverse functions. First of all, their slopes are reciprocals. Now the example I usually give is this. If you take e to the x and compare it to natural log of x, you take a point up here and you take its inverse point, which would be over here, those slopes are both positive. Now, they're not opposite reciprocals. That's when you have perpendicular lines. When you have inverse functions, their slopes are inverses. But they don't happen at the same point. In other words, this is what I mean. If I had an inverse function f, and let's say it contained the point 3,7, and let's say you knew the slope at 3 was 2. Then you had this other function g that was the inverse, what point would it contain? 7, 3. And here's the key point. The slope of it, no, the slope would be 1/2. Remember what we just said? Their slopes are reciprocal. So as these slopes are getting steeper, these are getting less steep. So as this goes to 3, slope is 1/3. Slope 4, 1/4. 5, 1/5, right? They're reciprocal. So if this slope is 2, this slope is 1/2. But this slope happens at 3, this one's going to happen at 7. Okay, because 7 on this one is the input, where this one, the input was 3. So that, if you can remember those two things, that you're interchanging those, and their slopes are reciprocal, a lot of times you can figure out an inverse problem with just remembering those facts right there about the slopes being reciprocals and that they happen at those points switched around.
What do you do if you can't solve for y?
Well, that's what I was saying. So if you had let's just make up a real quick one here. So if I had a problem, let's come back to oops. Okay, come on. All right, so let me make something up here real quick. So if I had one that was y equals, so my f function was x cubed minus 2x plus 1. Okay, that's my f function. Now, you could not interchange your x and y's here and then solve for y. You just couldn't, right? You'd have y cubed minus 2y plus 1. You would not be able to get y by itself in it, okay? So let's say we knew, okay, so we could do f prime on this one. It would be 3x squared minus 2. Okay. Right? So we would know that f prime of 2 would equal what? 10. Okay? So a typical problem here might be let me think about what a typical problem might be. They might be, well, let me back up a minute. Let me erase that. I don't think, put me on the spot here. Typical, and so G is the inverse. You'd be told G is the inverse. What they might ask you is for G prime of 2. That's what they might ask you. They might ask you what's G prime of 2. Okay? So what you would need to do is you would need to think this way. You would say, okay, the G graph is going to have a point 2 something. Right? That means the F graph would have a point what? Something 2. Right? So how would I figure out this something? Put 2 in up here. So, and solve it. So what you would have to do, and here's where everybody always misses this one, is they always want to take a 2 and put it in the input of F. 2 is the input of G. That means it's the output of F. So now you would solve this. So on your case, somebody got a calculator handy? We'll just pretend. Let's just pretend. Let's pretend we solve this and we get 5. So we would get our calculator out, or if it was a no calculator, it'd be an easy one to solve. And let's say we solve it and we get x is 5. So what's that tell us? That tells us x is 5, which tells us this is 5, right? So now what do we know? Well, what could we find out? Now we could find f prime of 5. Are you with me? If I would now do f prime of 5, and f prime's easy because here it is right here. So 5 squared is 25 times 3 is 75. 75 minus 2 is 73. So f prime of 5 is 73. What's g prime of 2? 1 over 73. And that's how that information would help you. So they would say, what's g prime of 2? You'd have to realize that, okay, an input of 2 in that function is an output on the f function, and make that your output. Find the input. That's how I mean, they're not that bad, but you got to have all those pieces in line to do it. Okay? And in the end, if it's one that you have to skip, well, there should be a lot of other ones we know, right? And look at that, you can miss 8 and still get an A. Right? You can miss 8 and still get an A. So, but it'd be cool to be able to get one like that. All right, well, I've taken up a lot of time. So, let's go ahead and let you work here. If you've got questions, let me, help you out. Now, again, it's not like you have to have all of these done, but man, if you do, and here's the advantage. I will just tell you, the advantage by Monday to having all of these done and thought about them and worked through them is then if you've got questions and we talk about them, it just makes that much more sense. If you haven't even looked at them and then I come up here and talk about them, you say, oh, okay, that makes sense, but you don't know if you could have ever thought that through yourself. So if you've already spent time thinking about them, that's the best thing. Yes?
When's our second final?
So we're going to go tomorrow, Tuesday, Thursday, Monday. So every other day, basically. All right.
Is it real? Did it actually